Unit 8, Lesson 1. We're going to connect algebra and geometry through its coordinates, and for Lesson 1, we're searching a region in the plane. So the question is, what type of math is involved in programming a robot to vacuum an empty room? And after you've watched the video, hopefully you've noticed or put together in your mind the movement of a mechanism can take or go or form in order to create things mathematically. So hopefully you thought of some things that are very similar to what I'm going to tell you. If you had mentioned or thought about anything with distance, angles, slope, lines, equations of lines, graphing on the coordinate plane, scale, rate, time, triangles, and right triangle trig, those would all be great suggestions. So let's write some of that down. EQTNS is an abbreviation for equations. Graphing on the coordinate plane. Scale, rate, time, triangles, and right triangle trig, to name a few. Okay, so the student outcomes for this lesson is given a physical situation, for example, a room of a certain shape and dimensions with objects at certain positions and a robot moving across a room, students impose a coordinate system and describe the given in terms of polygonal regions, line segments, and points in the coordinate system. So if you pretend that the floor is a coordinate system, the movement of the robot is in terms of line segments and points. This leads to graphing inequalities and discovering regions in the plane, which can be defined by a system of algebraic inequalities. So after watching the video, can you add anything to our list of how math is involved in programming of the robots? So hopefully you were able to witness and also determine that in order to program the robots, you have to do so to have them move on lines cutting through these regions, rotating 90 degrees clockwise or counterclockwise about an endpoint. So here's our first example. Your mother received a robot vacuum cleaner as a gift and wants you to help her program it to clean a vacant 36 by 30 foot room. If the vacuum is at position 12:9 at time t is equal to 2 seconds and at position 24:18 at t is equal to 5 seconds, answer the following. First thing you're asked to do is to plot the points on the given diagram. I'm going to do the best that I can given the circumstances of writing on an iPad. So my first coordinate is at 12:9. I obviously don't have 12 units here, so I take 36 and divide by 12, and I get 3. So each box is worth or is incremented by 3. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, and 36. So horizontally and vertically we're going up by 3s. Now we're going to plot 12, 9. And 24, 18. Okay, so draw the line connecting the points. You use a straight edge. I will do the best that I can with what I've got. Okay, how much did the x-coordinate change in 3 seconds? So keep in mind that the vacuum is at position 12, 9 at a time t equals 2 seconds and at position 24, 18 at 5 seconds. So the difference between 5 and 2 is 3 seconds. So they want to know the difference in the x-coordinate. So all I'm going to do is take 24 and subtract 12 and get a difference of 12. And how much did the y-coordinate change in 3 seconds? So that's 18 minus 9. That's equal to 9. And the ratio of change y to x, you've seen that before as the average rates back in Algebra 1. So that is slope. And since I have the change of y already, that's right here, I'm going to put that over the change of x, which is right here. And I'm going to reduce. So we get 3/4. So what does this represent? It represents the slope of a line or the average rate of change. Or the slope of the 2 points. What theorem could be used to find the distance between the points? We can use the Pythagorean theorem. But the only way we could use the Pythagorean theorem is if we dropped a perpendicular here and we drew a horizontal along here to meet that perpendicular. We get our right angle. And we could just count 1, 2, 3, 4. And then we can count 1, 2, 3 for this leg. And then 4 squared plus 3 squared is equal to c squared, the value of the hypotenuse, hence the distance of that line. Or how far did the robot travel in 3 seconds? You can use the distance formula. So either use Pythagorean's theorem or the distance formula. I prefer to use Pythagorean's theorem. It looks easier to use. Those of you who would like to use the distance formula, I will write the formula out for you, but inevitably you're going to have it memorized. So that's the square root of the change of x square plus the change of y square. Okay, but I'm going to use Pythagorean's theorem. So 4 square plus 3 square is equal to c square. 16 plus 9 is equal to c square. So 25 is equal to c squared. The square root of 25 is equal to c, so c is equal to just 5. So the robot traveled 5 feet. So that's a Pythagorean triple as well. During the duration of 3 seconds. If we were to allow the robot to continue on with this motion, it would hit the wall. Let's make some predictions. Which wall will it hit? So if we extend this line out, implying that we're going to continue with the same slope, it appears as though it's going to hit this wall here. So I'm going to say the vertical wall to the right. With 3/4 slope. Right, so if we go up 3, 1, 2, 3, and over 4, 1, 2, 3, 4, it's going to hit the wall right here. X marks the spot. So approximately where will it hit? Well, obviously at the 36 up to the 27 mark. So what is the speed of the robot in feet per second? So we already know that it's traveling at 5 feet for 3 seconds. So if we take 5 and divide it by 3, we get 1.7 feet per second. FYI, speed is a formula that's equal to distance divided by time. Where will the robot be at t equals 8 seconds? Well, if we know that it's at 1.7 feet per 1 second, all we have to do is multiply that to 8 and get 13.6 feet for 8 seconds. The formula for that is rate times time is equal to distance. And the total distance the robot traveled from t is equal to 2 to t is equal to 8 is 13.6 minus 3.4, and that's a difference of 10.2 feet. A baseball player hits a ball at home plate at position 0-0. The ball travels at a constant speed across first base at position 90-0 in 2 seconds. Okay, so from here to here is 2 seconds. What was the speed of the ball? So I told you already that speed is equal to distance divided by time. And we know that the distance is 90 feet divided by 2. So that's equal to 45 feet per second. When will it cross the fence? At position 300. Well, we know that distance is equal to 300, right? And it's traveling at a constant speed of 45 feet per second. So I'm going to take the 300 and divide it by the rate in order to get the time. Okay, so t, we knew that RT is equal to D, so if we take R and divide it out to get time, that's how I get the formula. T is equal to D divided by R, which is what we just did, distance divided by rate, and the quotient amounts to 6.7 seconds.